we want to look at sodium in this video. Now, pay attention that sodium belongs to alkali metals, group 1 of the periodic table, because it has one valence electron in its what? It has one valence electron, that is one electron in its outermost shell. Now, let's look at the extraction of sodium. You see, sodium can exist in different combined states. For example, sodium chloride, sodium triazocarbonate 4. In fact, sodium trioxonitrate 5. These are the natural form in which sodium can exist. Remember, it is highly reactive. It cannot exist free in nature. That is not possible. Good. Now, let us now look at how sodium is being extracted. You see, sodium is extracted using this electrolytic cell called the down cell. Called the what? Called the down cell. We call it the what? The down cell. This is called the down cell. Good. This is the apparatus we use for the electrolytic extraction of sodium. Now, in the down cell, let's look at this apparatus very well. We will observe that the cathode is made of steel. Don't forget, the cathode is the negative electrode, while the anode is made of graphite. The anode is the positive electrode. Now, what is the electrolyte? The electrolyte in the down cell is molten sodium chloride. You see, in this electrolysis, calcium chloride is always added. Calcium chloride, that's CaCl2. Calcium chloride is always added to sodium chloride. Why? Don't forget that the melting point of sodium chloride is about 801 degrees Celsius. So, in order to reduce the cost of electricity that will take for you to get to this melting point, we need to add an impurity to this molten sodium chloride. Don't forget that whenever we add impurity, we are trying to reduce the melting point. Good. Calcium chloride is added to molten sodium chloride in order to reduce the melting point of what? Sodium chloride. Good. So that's the role of calcium chloride in the extraction of sodium. Okay, now what happens in this electrolysis? Don't forget, let's look at the reaction at the cathode. Don't forget, sodium is that element that is deposited at the cathode. And how is it deposited? Sodium ion from the molten sodium chloride, Na plus Cl minus. Sodium ion will accept electron from the cathode and become what? Sodium metal. So this sodium here is deposited here. Are we together? Sodium ion receive one electron from the cathode and get deposited as sodium metal at the cathode. So what happens at the anode? Don't forget, the other species that we have is what? Chloride ion. Okay, that's one that is being what? Liberated at the what? At the anode. And look at the equation. So it will lose 2 electrons to become chlorine gas, and that's it. Now, the reaction that takes place at this cathode here is called what? Reduction. This is a reduction reaction, and the reaction that takes place at the anode is what? Oxidation. Guys, don't forget something. Cathode, the reaction that takes place at the cathode is reduction. Anode is oxidation. You can remember with this shortcut, CRAO. Cathode reduction, anode oxidation. And guys, that is it. So look at it, chlorine is being liberated here. So this gas liberated at the anode here is chlorine gas. And this is the end of the down cell. So we can now take our sodium that is being obtained on the cathode. Thanks for watching.